All right. 2 sum 2 input array is sorted. Given a 1 indexed array that's already sorted in non-decreasing order, find two numbers that add up to a specific target number. Let these two numbers be numbers index 1 and numbers index 2. Okay, so I want to return, excuse me, I want to return the indices of the two numbers index 1 and index 2 added by 1 as an integer array of length 2. The tests are generated such that there is exactly one solution, and you may not use the same element twice, and constant extra space. So what stands out to me is the sorted in non-decreasing order. This tells me that this could be a two-pointer pattern, and also that you must use only constant extra space. Okay. So I'm thinking that this could be a two pointers problem, where we have a left and right pointer. I'm thinking that since the input array is already sorted, we can use the two pointer pattern starting from the left and the right, and we can add them together, and we can say, hey, since 2 plus 15 is 17, and 17 is greater than our target 9, then we can move the left or right pointer accordingly. Okay, so to plan out the problem, I would say declare our left and right pointers. Okay. Then we need to say loop through numbers. Add left and right together. If the current sum is greater than target, then move left pointer forward. If the current sum is less than target, if the current sum is greater than our target, then we need to move the right pointer in. So move right pointer backwards. If the current sum is less than target, then we need to move the left pointer forward. Okay. Okay, to implement, let's first declare our left and right pointers. Left is equal to 0, right is equal to the length of numbers minus 1. And when we loop through the numbers, we can say while left is less than right, we will have a current running total. So we can say sum is equal to, maybe it's easier to see it like this way. at the bottom. I'll put it right here. While left is less than right, current sum will be numbers left plus numbers right. If the current sum is equal to the target, then we can return the indices added by 1. So return left plus 1, right plus 1. Otherwise, if the sum is greater than the target, then we need to move the right pointer inwards or backwards. So right minus equal to 1, and otherwise sum is less than target, so left plus equals 1. Okay, and then they add up to a specific target number. Okay, what else do I need to do? So let's review with this input example. If left is at 2 and right is at 15, first I would add them together for a running sum total, so 17. Since 17 is greater than target, right, and the right pointer would be moved backwards or inwards 1, so right would be at 11. Next iteration of this while loop would be 2 plus 11 is 13. 13 is greater than 9, so you move it back again. So 2 and 7 is 9, and 9 is equal to the target. And the tests are generated such that there's exactly one solution. So I think every example will always return a solution based on the test cases. So to review, the time complexity is O of n for this one single while loop, and space is actually what is space? I'm wondering if space is O of n. I believe it is. Where right is the size, where right is affected by the length of numbers. Why do I think it could be O of 1? I might have to review this. That's a good thing to review because there's no like list or set or map being created. I believe it is O of n because I would say because of right, or is affected by the length of numbers. All right, let's give it a go. Let's try it out. Okay, the code works. That's good. Now I'm gonna submit it. I wonder if I can get a time and space analysis for free. O of n, okay, for time and space. It's O of 1. Okay. So, hey, thank you for this premium feature freebie to actually O of 1. And actually that it says, what does it say? Constant extra space. So O of 1 is actually constant and O of n it would be linear. So actually O of n would not be a viable solution. Anyway, okay, O of n and O of 1. Okay. Submit. All right, it sounds good.